Welcome back to CJay's video notebook. This is part 2 of our DOL motor control basic series. In this video, we're taking your understanding to the next level, exploring control circuits with status indicator lamps, push-to-test functions, and relay-based logic. This is a direct online, or DOL starter circuit, the simplest and most widely used method for starting induction motors. The three-phase power supply enters the system through a protective circuit breaker, then flows to the magnetic contactor. From the contactor, the line continues through the overload relay and finally reaches the electric motor. On the front of the contactor, you'll notice two wire terminals labeled A1 and A2. These are the coil terminals. When a control signal output voltage is applied across A1 and A2, the coil energizes, pulling in the contactor to close the main power circuit. In the upcoming slides, remember this key point. The signal we'll refer to as S1 output corresponds to the activation of this magnetic contactor. It's this S1 output that energizes the coil via terminals A1 and A2 as illustrated here. This control circuit builds on the basic single push-button motor starter by adding two status indicator lamps using auxiliary contacts. The green lamp lights up when the control circuit is energized and the motor is ready to run. Once the start button is pressed and the motor starts, the red lamp turns on to indicate that the motor is running, while the green lamp turns off. This is done by mechanically changing the state of normally open and normally closed auxiliary contacts on the motor starter. In more complex applications, control relays like ice cube relays or force-guided relays may be used for similar functions where safety or multiple pole switching is needed. This circuit is similar to the previous one with status indicator lamps, but instead of using auxiliary contacts from the motor starter, it uses a dedicated control relay to operate the lamps. When the circuit is at rest, the green lamp is lit using a normally closed relay contact, and the red lamp is off. Pressing the start button energizes both the motor starter coil and the relay coil. Once energized, the relay changes contact states, turning off the green lamp and turning on the red lamp to show the motor is running. This setup uses an 11-pin octagon base ice cube relay, often used when more switching options or electrical isolation is needed. This circuit works like the previous one, but here the control relay not only controls the indicator lamps, it also energizes the motor starter coil. The key benefit is that if we use a force-guided relay, all parts of the circuit will change states together, adding an extra layer of safety and coordination. Also, the holding circuit uses the contactors holding contact instead of the relay. That way, if the overload relay trips, the entire control circuit resets and stays off until the start button is pressed again, keeping the system safe and preventing unwanted operation. This circuit uses an indicator lamp to show when the motor is running by lighting up whenever coil S1 is energized. It also includes a push-to-test feature, which lets the operator manually check if the lamp is still working. The S1 coil and lamp are wired in parallel to receive the same voltage. Pressing the test button momentarily disconnects the lamp from the normal control circuit and instead connects it directly to the power line. If the lamp lights up, it's good. If not, it likely needs replacement. This is useful when the motor is far from the control panel and lamp failure might go unnoticed. That's it for part 2 of our DOL motor control basic series. In this episode, we explored circuits with status indicator lamps, control relays, and even push-to-test functions, essential building blocks as we move into more advanced control systems. But the learning doesn't stop here. In part 3, we'll dive into even more complex motor control circuits, featuring interlocks, multiple motors, safety relays, and real-world applications that every technician and engineer should know. So stay tuned right here on CJay's Video Notebook, your go-to channel for hands-on electrical learning. Don't forget to like, comment, and subscribe so you never miss an upload. Thanks for watching, and I'll see you in part 3.